For this particular part, we're going to be doing a 4-axis toolpath. Okay, we're going to be setting this all up, but I'm going to do this a little bit differently than I did last term. Instead of going side by side, I'm going to be going tool by tool. And the benefit to doing it this way is to minimize your tool change time. If you're running a lot of different tools and you're only running one side at a time, you're going to have probably 4 times the number of tool changes, 5 times the number of tool changes that you would otherwise. So depending upon how fast your machine is, and this is really kind of where you got to be thinking, some machines rotate very slowly, and in that case, the tool change time is actually quicker than the rotation time. So be thinking in those terms. How fast is my rotation? A lot of the newer, more modern machines, very, very fast. I believe the Sudocomos that we have on the 560s we have at the college, they can turn over 300 RPM. So that's extremely fast. Most 4th axis won't turn more than maybe 10 or 20 RPM. So just to give you an idea. So some are very slow, some are very, very fast. So depending upon what it is that you need to do, that's going to kind of determine the order at which you're going to be doing things in. So in this case, last time what we did is we did plane by plane. So we started off with our number 1 plane, and then we worked everything on that side, and then we rotated our part, did everything on the next side, and then so forth, on around the part. Now, the way that I have this set up, if I press F9 on my keyboard, I can see where my center of rotation is, and this is kind of where we're going to be basing everything from. So when I go to create a new plane, I'm going to be looking at what first side I want to be using. I'm going to go ahead and drop into that particular plane. So let's go ahead and go to top, and let's go ahead and go to view, isometric, so that we have an idea of where the very first base plane will very likely be. So I'm going to go ahead and work from this plane, my top plane first, and then I'm going to go ahead and base everything off of this plane. Now the same is also true if you're working somewhere off in space. Then you're going to have another base plane wherever that's going to be off in space, and then everything's going to be based upon that home plane. The home plane is always going to be married to your WCS. That will not change. So now that we're going into multi-axis, and we're going to be doing some really crazy stuff, especially when we get into the 5-axis stuff, and we're going to be doing some really, really awesome, wicked things around. And I was just reviewing all the files we're going over. About week 9, 8, and 9, that's when we get into some really funky stuff. It's going to be a lot of fun. So for our first side here is going to be this one right here. And I'm just going to go ahead and use this as my base plane. As I add planes, my WCS is going to stay here on top. Okay. So the first toolpath that I'm going to go ahead and run, and I'm just going to go ahead and name my operation up here. So this is going to be, just a little housekeeping here. This is my op 1, let's say. And I'm going to go ahead and create another subgroup within this group. So I'm going to right click on the group itself, come down to groups, toolpath group, and this is going to be a tool number. I don't know what the tool numbers are yet, so I'm going to leave it right there. Let's go ahead and do our first toolpath. So I'm going to go ahead and go toolpaths. Let's do, let me see, for this one, probably a peel mill is going to work out really well. And I'm going to go ahead and chain in. Let's go ahead and try that again, because I want to do a partial. Do that chain. And then I'm going to go ahead and end that chain there, and then pick the other side. Oops. Let's get this going here. Okay, so now this is a, let me see, this is a peel mill, so I got to have the chains going the same direction. So just to explain that real quick, you can see the starting points and the ending points are matched. They're lined up. Okay. And let's go ahead and pick our tool. Okay, so looks like we're going to go ahead and use our 3/8 tool. So I'm going to go ahead and name my group tool number 2. And this is going to be whatever. This is a peel mill. I'm going to go ahead and comment this. And it's important that you try to note what's going on here. And with this peel mill, I can use a finishing operation. I'm also probably going the wrong direction, to be perfectly honest with you, because this is my sub spindle side. I probably don't want to start over there, so I'm going to go ahead and reverse those chains. So I'm just going to come in here, I'm going to right click on one, reverse that chain. Well, it should reverse it, and then reverse. There we go. And reverse. And then hit regen. Now that should get it going the proper way, so I'm not spilling over too far. If we have this set up and we don't have it set up properly just right now, I would actually have the fourth axis drawn over here with all the fixturing and everything ready to go. Okay? So that I know that I'm not going to be colliding anything that I don't want to collide into. We'll get into that a little bit deeper a little bit later. But for this particular operation, I'm going to go ahead and call this tool number 2. And this is a 3/8. And I'm doing that so that I know what tool is where, and I'm going to do all of my tool number 2 3/8 operations, and even when I'm flipping sides. So depending on what direction I want to go, it doesn't really matter what direction I go. I can just go ahead and use that 3/8, and we're just going to go ahead and spin this thing around. I will need to create a new plane, and I'm just going to go create a new plane from a solid face, pick my face, and say OK, and then I'm going to go ahead and reselect my origin point once I get to the place I need to be, and this is going to be, I'm going to say plane -2. Actually, I'm going to say plane 90. Let me see. So after we get this, I'm going to go ahead and say OK, and then I'm just going to go ahead and hit my busted 0 down here, since that is my 0 location. And that's my plane 90, and I'm going to set my construction plane tool plane to that side, go back into toolpaths, and I'm just going to go ahead and continue with this subgroup right here. And we're going to go ahead and do a dynamic. And for the machining region, I'm going to go ahead and pick this chain here. I'm leaving this end open for a reason, because we can. And I'm going to go ahead and say OK, but I do have an avoidance region, and that's this inner pocket here, or this inner up sticker right there. I'm going to go ahead and say OK, that's the avoidance region. And we're going to be doing the from outside on that strategy. I'm going to go ahead and say OK. And we're going to be using the same tool that we just used. And this is going to be plane 90 and dynamic and 3/8. So whatever you want to use for your naming convention for the comment here, try to keep it standardized, and it can be anything that you want as long as it makes sense, of course. So obviously we're not getting into the corners or into the gaps in between here. So let's go ahead and I think I can reduce, yeah, the minimum tool radius here. I'm going to cut that down to 3. I'm going to leave the step over kind of high. Oh, and this right here too. I'm going to get that down to 10. So that should do the whole thing now. On that particular side. And by the way, I am using the HLE just to make sure that everything will be working for you guys too. So in the event that there are any problems, I should see those problems right along with you. So it looks like the step over is way too small. Let's see what I did. I think I screwed. Oh yeah, let's try that again. That's why it did that. There we go, much better. Okay, then moving right along, we're going to go ahead and create another plane, and we're going to go ahead and do this side right here. From a solid face, pick a face, and this is going to be plane 180. And I'm going to go ahead and use the busted 0 here to reduce it back to 0, so that is my 0 point. Notice how my X is going the wrong way. I want my X to actually be pointing, no, to be honest, that one's wrong too. Now, in order for this to be right, and I'm going to have to go back and fix this, but the beauty of it is I can always go back and repair the plane. But right now, so if I look at my top plane, see the direction my X is pointing? That needs to be the same throughout everything that we're doing on a 4-axis. The X is always going to be pointing in the positive direction for the X-axis. If the 4th axis is mounted so it's rotating on the Y, then the same is going to be true for the Y-axis. So the Y's would always match. And you always have to make sure that you have it oriented properly for the positive direction. So the top plane is fine. This plane here, the X is not okay. I'm gonna have to adjust that, but I cannot move the Z. The Z's got to stay the same. So I go to Edit, and then I'm going to go ahead and drag my X around where I need that to be, and then say OK. So now that's corrected, and then I'm going to go ahead and highlight that, say Edit, and again, I cannot change the orientation of the Z-axis. That has to stay there, and I'm just going to go ahead and drag that around until that's pointing in the direction that I need that to be, and I'll say OK. And now that plane is correct. So now that we have that one correct, I can go ahead and do the programming for this particular side. And let's go ahead and do, let's do a blend mill for this. I think that's what's gonna work. So there has been some advances with blend mill. However, there still are some issues as far as having the choppiness on the side here. So we're going to go ahead and finish the floor here, but we're going to use a contour to finish the wall. Contour is always going to be your #1 go-to for finishing. It's got your most power. It's got the most capabilities. So using these dynamic toolpaths to rough everything in and then go back with a contour is actually a really good strategy. Some of the dynamics like peel mill does have the contour sort of built into it, and that works just fine too. But for blend mill, it's not quite the same thing. So I'm going to go ahead and pick the line out here for the initial part of the blend, and then I'll end that chain, and then I'll pick this one in here. And the same tool. And let's see about the cut. So I'm setting it to left. And I do believe, yeah, that's the one that we want for that. I'm going to go ahead and say 10 thousandths and say 20 thousandths. No depth cuts, not worried about finish passes, linking parameters, haven't really covered that yet this term. Pretty much the same stuff that I always use. 2 inches, especially when we're talking about clearances. I'm going to have to go back through and actually correct the other ones. But since we are in basically a 4-axis mode, I want to be all incremental over here. This is kind of where we make sure we definitely make that switch. All of our distances here need to be incremental. So top of stock, depth, and of course that's based on where I chose the geometry. So in this case, top of stock is 200 thousandths above where I chose the geometry, and that should be about right. Arc filter tolerance, this is a roughing toolpath. I could give it more here, but this particular toolpath is inherently a little bit more facety. It does some flats more so than others. But if I'm leaving 20 thousandths, I can use half of that. I can go 10 thousandths. Okay, make sure the plane that I'm using is the correct one. And there's that blend mill. So that's going to work out just fine. And I believe that's zigzagging. I believe that can go one way. So let's see here if I can make that go one way. Yep, right there. So one way. And it should start from the first entity that you chose and then work its way. So if I go into backplot here and do a quick check, yeah, so it's starting on the outside and it's going to work its way in. And then notice that even though I'm here, this is the end where my rotary axis is going to reside. So that's going to be just fine. However, the heights here, it's kind of scary. I don't kind of like that drop down as it's going in. So let's take a look here. So always be paying attention for those kinds of things. That's going to be a linking deal. Let's do a retract. And I want to do an incremental. Let's do 0.5 so that we're at least at 0.5 above. And regen. There we go. That looks a lot safer. Okay. So Mastercam is going to be pretty good about letting you know what's going to work or what's not going to work. And in the event that this is not going to be far enough of a lead-in for you, then another thing we can do is we can extend those lines. So if we go into wireframe and then I come over here to modify length and I want to extend or lengthen, and the diameter of my cutter is 0.375. So if I go at least half of that, if not more, I'm just going to say 0.2. And then I extend the length here by 0.2, just those two. Then what that's going to do is that's going to give me an extra lead in on that without having to affect anything else inside the toolpath. But unfortunately that does not work with solid chaining. If you're using the solid edge, that would be a little bit different. I do believe we have the ability to do that. So extend right here on the entry, and we can extend the exit. So if we wanted to extend the entry, we can do that by 0.2 and get the same result, and then you can use the solid edge for your chaining. So I'm just going to go ahead and those two are actually, let's trim them. So I'm just going to go to wireframe, trim, that to there, and that to there. So we should have the same exact result. So there, we have the extra lead in. It's not leading out any because we really don't have to. Bear in mind, we're going to have fixturing or the subspindle, or it could be a subspindle, it could be fourth axis on this end. It just depends on what's going on. Now for the final side here, and again, this is just roughing the part out. Again, we're going to have to go back in, create a new plane. So let's go ahead and go to planes. And then we will go to from a solid face, pick our solid face. And let's go ahead and say that's going to be 270. And we will go ahead and reset our location. Check our x-axis. It's not quite right, so I'm going to go ahead and adjust it. So I'm going to go ahead and edit that plane so that the x is pointing in the right way. Please pay attention to this. I can't tell you how critical this is. I had an issue one time on a 5-axis. This was actually a UMC 750 Haas 5-axis machine. They're actually fairly decent. I know you'll hear me bash on Haas quite a bit, but they're actually fairly decent. I had the x-axis pointing in a weird way, and the machine did not react the way I was anticipating. In other words, it looked fine in Verify. I was anticipating to see something specific on the machine through Verify. When I took the program out to the machine and then ran it on the machine, I got a completely different result. Because one of the things that you're going to learn, especially this term, when we talk about 5-axis, and this is going to be one of the things that you're going to have to remember. So you might want to write this down somewhere. On 5-axis machines, there's always two possible solutions. You can change the biases in the post-processor to affect one bias over another. In other words, a C-axis rotation positive over negative, let's say. This is going to become more apparent when we actually look at the machine simulation when we do 5-axis work as to which direction that 5-axis is actually going. So you can get the wrong solution. If you get the wrong solution, then it's just a matter of trying to control that bias so that it goes the correct way. But another thing that affects that bias is the direction that your planes are set. So if you got the X going in the wrong way, you could end up, even though you got your switches set properly for your biases, it could still go the wrong way. So it's going to look okay and Verify, and it's going to be really wrong on the machine. So that's one of the things you got to really pay close attention to. Okay, so now that I got that plane set, now it's just a matter of doing the toolpath. And for the toolpath, let's just do a dynamic mill for this one. machining region. And we'll say OK to that. And then the avoidance region is going to be this center piece. And I'll say OK. Same tool. Cut parameters. Let's see here. I think we're OK on everything there. I'm just going to go ahead and say OK. And that's going to be that right there. Looks like it's kind of going over. Yeah, let's change the strategy on that. Looks like we got the wrong strategy going for us here. So I'm going to go back to my toolpath type and stay inside, say OK. And then we'll regen that. Yeah, it's not going into those corners now. And we can hopefully adjust that out. Maybe, maybe not. It's awful close. Of course, if I were to cheat, I could go ahead and reduce the size of this so that it would work no matter what. The other thing too, I could use a 1/4 inch too, but that's going to be part of a different toolpath group that we're going to be using. So for right now, we'll go ahead and rough it out with that. And that kind of finishes out the first toolpath group. So from here, since that's kind of roughed out a bit, if I wanted to change the tool size and do basically the same thing, one of the things I could do is I'm just going to go ahead and right click on my number one operation, come down to groups, new toolpath group, and this is going to be, say, tool 3, and this is a 1/4 inch. And then I'll do everything that I need to do with this particular end mill. Notice how my plane is different up here. So I have my top plane, plane 90, plane 180, plane 270. I can do the same thing with the 1/4 inch down here. Now, if I didn't like it, well, let's just go ahead and I'm just going to go ahead and copy all of those toolpaths into that next toolpath group. And all I'm going to do is go back in and I'm going to change to the, oh, I'm sorry, that's tool number 4. So let's go ahead and fix that. For the 1/4 inch end mill. So I'm going to go ahead and change this, make this correct to tool number 4. And then we're going to go ahead and change this to the new tool. We're going to use all the same parameters. And then hit regen. And of course, I'm going to have to go back in and do some modification. But depending upon what you need to do, I could possibly use the 1/4 inch for finishing. There's also a number of other things too that I can do. So the 3/8 left on this particular face a gap in here that didn't get cut. So I would then use the stock model option and then create a stock model and then have it figure out what got missed and then use the 1/4 inch to go back in and just pick out what it didn't get and then go through and do a finishing pass after that. And then since that's pretty much, yeah, let's go ahead and leave that right now the way that that is. What I would do though is I would adjust for this 1/4 inch the stock to leave on the floors to 0 on all of them. So let's do that. Stock to leave on the floor. So it's going to finish the floors on everything, and then we'd go back and actually finish it with, say, just a regular contour toolpath. And we'll go 0. And I'll regen all that. So that's actually going to finish all the floors. Then I'd go back in with another toolpath or another set, and then finish the walls on that, possibly with even a smaller end mill like a 3/8 or whatever else, or possibly another 1/4 or anything that might fit. Frankly, a 3/8 would actually still fit. So I could get in there even on this face. There should be enough room between these two faces to get the 3/8 straight through it without having to worry about anything else. And then, of course, the last thing that I want to do for this, I'm going to go ahead and move my arrow down to the bottom, is do some chamfering. And if I don't have a chamfer tool, let's go into our tool manager. I want to see what I got for tools. Oh, I got a 1/8 chamfer tool right there. So tool number 3 is going to be our chamfer tool. So I'm going to go ahead and right click on my op1, go down to Toolpath groups, create a new group here, and this is going to be tool 3. And a 1/8, let's see, 1/8 chamfer. As soon as I learn how to type here. Okay, and then I'm just going to go ahead and go to my top plane here. And I'll go to View, ISO. That's going to get me to here. So then I can just go ahead and do some basic chamfering operations. And I only want to worry about chamfering the inside here. So I'm going to assume that the outside edges here are already chamfered or possibly been already worked. Otherwise, if you include these edges on all 4 sides, you're going to have some duplication. And of course, duplication means extra runtime. So we'll just go ahead and go to Toolpaths. We'll do a regular contour, and I want to do a chamfer. Let's see here. Partial. And solid edge. Let's pick that solid edge right there. Nope. There we go. That's going to get what I want. And we'll end that one there. We'll grab that one and end that one there. Okay. For the tool, let's go ahead and pick our tool number 3. And we're going to do a 2D chamfer. I'm going to set it to the top offset, and I'm going to give this 20 thousandths. What that means is the corner edge of my 1/8 diameter chamfer mill is going to be 20 thousandths above the surface of whatever it is that I chose. And for the size of the chamfer that we're going to be cutting, let's see here. No depth cuts. Yeah, let's reduce that by quite a bit. And extend the length a little bit. So chamfer width 10 thousandths, top offset 20 thousandths. That should be enough to get all the way around where we want to go. Okay, incremental. Top of stock. Oh, let's try incremental on that. There we go. Okay, so that's going to give me my chamfer on those edges. Then we'll go to our next side here. I'm going to do the same thing, but what I can do is copy this down. Just remember though, we're going to have to change the plane. We're going to have to change the geometry. So I'm just going to go ahead and go to my parameters, come down to planes, and I'm going to pick the new plane that I want to use, which is going to be that 90. Okay, and these two need to match. So your tool plane, construction plane must match. My work coordinate system, my WCS, must always stay on top. Okay, this is what differentiates or tells Mastercam we need to rotate. Otherwise, if these all stayed the same, Mastercam wouldn't rotate the axes at all. It would stay at A axis 0 and try to run whatever you programmed on the wrong face. So once that's all set, then it's just a matter of reassigning the geometry. So we're going to go ahead and come in here, rechain all, solid edge, and let's go ahead and say OK to that one. And here, reverse it. Because you got to be thinking tool on the left hand side, so hopefully it's going to be going the right way here. Yep, got it. And we'll regen. Now as long as you got the plane set right. Okay. Okay, so there's that, and there's that. So it looks like it's got something funky going on with the linking. Let's try that again. Ah, absolute, that's why. There we go. That was the problem. Just had to make sure that that was on incremental. And now we're good to go on that face. I'll go ahead and rotate to the next face here. I'm going to go ahead and chamfer this edge too, even though it's a different height, and chamfer this one here. So, and again, since we're on incremental and it's at 0, it's going to be able to adjust the different heights, even though it's still within the same operation. So I'm going to copy this one down, and I'm going to make the same changes. So I'm just going to go back in, change the planes. Okay, so now I'm on 180. WCS stays the same. Then it's just a matter of repicking the geometry. So I'm going to go ahead and do a rechain all. And we are at edges and thinking cutter comp left. So I want that one and that one. And we'll say OK. Looking good. I'm going to go back in, double check my linking. Make sure it didn't, it jumped up to absolute for some reason. So I'm going to pop that back down in incremental. And it should be okay. So then we'll regen. There we go. That's looking like it should. No problems there whatsoever. So I'm going to go ahead and rotate around again. And I'll copy this down. And there is a reason why I want you guys to go through this repetition, okay? Because we're going to be building upon these skills. So please take the time to practice. And for our planes, let's reassign our new plane. We're going to go to 270 this time. And our geometry. Okay. Oops, let's back up one. There we go. And again for our linking, because I think that's going to be doing that from now on. Yep. So let's go ahead and make sure that that stays on incremental. And then we will regen that. And there we go. That's looking like it should be. And then ultimately what we want to do is at the end of each tool, create a stock model. And so you can see what's going on with the stock model at the end of every tool. And as long as you're working 90 degrees out from each face, if you go into verify, it's not going to blow through your part. Know that you're going to have probably that instance. However, the funny thing is it doesn't normally do that on the machine simulation side. So that's going to work out just fine. All right. So for now, this is what's going to be our practice for this particular lesson. What I want you to do is go ahead and set it up the way that I have it here. So we're set up by tool. So we have our op 1, and then our tool number 2. That's all that tool number 2 is doing. Then our tool number 4, and then our tool number 3. And again, we're rotating. So we're trying to save on tool changes. So right here for this particular program, we have 3 tool changes. If we were to do this the other way, where we worked on each individual face, we would have 12 tool changes. So you can see kind of the difference between the two. And again, it's going to depend upon which is really faster on your machine. Is your rotation axis really fast, or is your tool changer really, really fast? So more often than not anymore, it's going to be faster to save yourself on the tool changes instead of the rotationals.